With questions like this, there's often a hard brute force method and a far easier method. And in this case, even though the coefficients do look a little bit horrific, there is a relatively simple path to the answer. So let's go. First of all, as we have two complex roots here, by the complex conjugate root theorem, as we know that 2 plus 3i is a root, we also know that 2 minus 3i is a root. And as we know that 3 plus 2i is a root, we also know that 3 minus 2i is a root. So what we could do is we could say, okay, well, therefore, x minus 2 plus 3i times by x minus 2 minus 3i times by x minus 3 plus 2i times by x minus 3 minus 2i would give us a quartic. Then we could divide that quartic into the sextic, which would give us a quadratic, which we could then solve in order to get the other two roots. But there's a far easier way. Okay, so let's first of all have a look at what this thing looks like roughly. As the coefficient of x to the 6 is positive, we know that roughly it looks something along the lines of this. We don't know exactly, but that's basically what it is. Now, the four roots that we know are complex, so we know that two of the turning points are above the x-axis, and this third one here, if the other two roots are complex, will also be above, but if they were real, then it would move down here instead of being there, and then basically the answer to the question would be the length of this x interval here. Okay, so let's see what we're going to do. If we have a sextic y equals a x to the 6, add b x to the 5, add c x to the 4, add dx cubed, add ex squared, add fx, add g, if we have one of those, well then the product of the roots is equal to g over a, that's the product of the roots by Vieta's formula, and the sum of the roots is equal to minus b over a, again by Vieta's formula. So if we look at the roots that we know, let's let alpha equal 2 plus 3i and beta equal 2 minus 3i, and let's say gamma is equal to 3 plus 2i and delta is equal to 3 minus 2i, and let's let the two roots that we don't know be lambda and theta. Then what we know is that alpha, beta, gamma, delta, lambda, theta is equal to 4732, which is g over a, just looking back at our thing there, 4732, and here's b over a, so therefore b over a, which will be alpha, add beta, add gamma, add delta, add lambda, add theta, is going to equal 21. Okay, so basically, as alpha and beta are conjugates, we can multiply them together and add them together very easily, because if we have two conjugates, a plus ib and a minus ib, when we multiply them together we get a squared add aib minus aib minus I squared b squared, which comes to a squared add b squared, because I squared is minus 1, and so therefore we know that alpha beta here is equal to 2 squared add 3 squared, which is 13, and we also know that gamma delta is equal to 2 squared add 3 squared, which is equal to 13. And therefore we know from this equation here that lambda theta is equal to 4732 over 13 times 13, which equals 28. Now, if we look at the sum, summing alpha and beta is easy because the imaginary part cancels out. And so therefore, from alpha add beta add gamma add delta add lambda add theta equals 21. We know that that is equal to 2 plus 2, which is 4. And we know that that is equal to 3 plus 3, which is 6. Therefore, we have 4 add 6 add lambda add theta is 21, i.e. we have that lambda add theta is equal to 11. And now what we need to do is we have that lambda add theta is 11, and we also have that lambda theta is equal to 28. Now what we could do is we could solve that by forming a quadratic and then factorising, but in actual fact we can also solve this by inspection. We have that lambda is equal to 4 and theta is equal to 7, or vice versa, it doesn't matter. And so now we know that the other two roots are real, and we know they're at 4 and 7. So if we go back to our very, very approximate graph here, in actual fact, we now know that our sextic looks something like this, where that is 4 and that is 7, and therefore, in answer to the question, the length of the interval of x for which y is less than 0 is between 4 and 7 here, which is 3, so the answer is D, a far easier way of doing it.